Hello everyone, my name is Fernando Teixeira and I'm a senior instructor at AWS, currently teaching at the AWS Cloud Institute. Let's talk about some key concepts on DynamoDB. Today I actually have the Grand Canyon on my background because, well, it beats having my basement as my background. And today's topic is different than the practical tagline that I have because I won't be looking at code here. But I was creating a practical video with code samples and everything, but there were a lot of basic concepts I wanted to make sure that everybody had. And I wanted to keep that practical one to strictly hands-on, so I decided to create this one on the side, and then I'm going to publish both of them together. Now, if you want to see that practical demonstration, check out the other video, and I'm going to provide the link below. All right, so let's get going. I want to start by looking at relational versus non-relational databases. Relational being the one that a lot of people have been used to over the years, and non-relational is where DynamoDB is going to fall in. So let's take a look at that. The relational table is like a spreadsheet. You have rows over here, and then you have columns over here. In this particular use case here, I did book sales. All of the books over here are fake books and fake authors. I'm using my bets. In a relational table, one of the nice things about it is that I can use SQL, the SQL language, to do queries that, well, relate, and hence the term relational, the two tables. So for instance, I can ask, all right, give me all of the books and their costs, but not every book. First, I want to say, where am I getting from? Well, I'm going to get data from both books and sales. But then I want to say, well, just give me the books for Tucker Blue. And when I did that, boom, I'm focusing on Tucker Blue, and I got that particular row on that table selected. But now I want to unite that, join that with my sales table. And I can do that by getting those two ISBNs, which is a book ID, and relating those together here, here, and here. And I've essentially created now this combined set of possible rows that satisfy my query. But I want to be even more specific, and I'm going to put a condition on the other table. I'm going to say, well, the sales cost has to be greater than $12. So now, I only have this one guy. So at the end, I end up with this one row retrieved in this very flexible way. Now, it is really cool for the queries, but then why do we even need something else? Well, relational tables do have a little bit of a problem because since I have these fixed rows and columns, if I were to want to add something over here, let's say I want to add a publish date, pub date. My writing, by the way, is horrible. That's why I do nice PowerPoints. Well, I would have to essentially open up some space over here and create some space for my publish date, because although I can have an empty value, there is an expectation that every value is there, and I'm going to pre-allocate data for that. And the other issue is, because I have all of those great relations, right, I end up creating a bunch of those links between those two tables, links sometimes even within the table itself. Well, now if I need to scale this, imagine that this whole table kind of became one big thing full of those connections. So I end up doing what we call vertical scalability, because I have to scale the whole thing, make this thing bigger. Oh, well, make this thing even bigger, the whole thing, because they all kind of tie down together. So because of that, we look at the flexibility of our non-relational tables. Now, the non-relational tables, and yeah, DynamoDB is going to fall on the category. They are not having the whole rows and columns anymore. What they'll have is what we call them documents. Which is not a name that I'm particularly fond of, but they're essentially JSON structures. I'm not a big fan, document, to me, document is like a Microsoft Word document. But yeah, if you hear people talking about a document database, yeah, that's because it's a collection of JSON structures like this that make up my data. Now, if you look at this, you're gonna see that I have both the books and the sales in the same JSON structure. So you might ask, hey, why couldn't you split up the data and put it over there? Because, yes, I do have a key that is common between the two of them, but I could have split them up. Well, the problem there is if I want to be able to do a query together, like I did with the case of the relational, and I want to compare oranges with oranges to be fair. Well, I would have to do one query on this key over here to get the book for Mr. Tucker over here, and then another query to get the sales for this particular ISBN. Because when I'm dealing with something like DynamoDB, I'm not gonna have that on the fly join. I'm pretty much only gonna have those kinds of key-based queries like this where I get the data based on the key. So that key-based query is going to be lightning fast, but I'm restricted to that or to additional keys. We're going to talk about that later. Now, advantages over here. Well, first of all, because I'm dealing with JSON and I don't have those fixed rows and columns, yeah, if I want to have a published state over here for this particular record, but for that one I want to have an edition, but I don't need a published state, yeah, that's okay. They're all individual structures. Now, the really cool thing about this is the fact that I now don't have that everybody's relating to each other is going to give me an amazing amount of scalability. And we're going to take a look at this next when we look at the DynamoDB structure. Let's take a look at this DynamoDB table structure over here. In DynamoDB, I'm not going to have those rows and columns. I have items. And those items are going to be made up of attributes. Now, in those attributes, I have one very important one. That's my partition key. We're going to see why coming up. And I can have an other one, an optional other special attribute called the sort key. Now, sometimes I only need a partition key, and that's going to be enough to be unique. But why is this partition key so special? Well, that's because DynamoDB is going to split my database into multiple partitions. Now, how many partitions? It's up to DynamoDB. That's the beauty of it. You're going to get the performance of having those partitions being split, but you don't have to worry about it because DynamoDB is going to handle that internally. Now, why do I care that there are partitions? Well, because you're going to see that they're going to improve your performance and scalability. Because when DynamoDB goes over here and tries to insert one of those pieces of data, it's going to apply a hash function. Now, if you don't know what a hash function is, it's just something that if you use a hash function and you give it a value, it's going to come up consistently with the same value within a range every time. So same value always yields to the same hash value. So it's going to take the partition key and it's going to hash that value over here and it's going to say, well, it's 1. Well, that means it's going to put that record on partition 1. Then for the second one over here, well, maybe the hash is going to be 3. Well, that means that that item is going to go on partition 3. Well, maybe that last one over there, when you hash, it hashes to whatever n is, that's going to go to partition n. Now, that's awesome, but then it doesn't stop there because, hey, I'm going to have more data. Yeah, it's not one partition per item. I'm going to have all the data. So I can have a lot of different people querying my database to get to my different data. So how do I improve my throughput? Well, DynamoDB can actually replicate each one of those partitions. So not only my data is split up across partitions, but I also replicate that data in multiple copies. Again, DynamoDB is doing that for you. You don't have to worry about it. So how is this DynamoDB structure helping my queries? Well, let's take a look at it. If I'm doing a key-based query like a get or query, those are the DynamoDB operations. And let's say I'm looking for the record that has this ISBN over here. Well, what DynamoDB is going to do is going to first hash that key into a number. And when I say DynamoDB is going to hash, DynamoDB is the only one that is actually calling that hash function. The example before that I mentioned, you are not hashing your key in your own hash function. This is internally done by DynamoDB, but it is important to understand that it's happening because even the programming interface refers to a hash key. So it's good to know that that's what's happening inside DynamoDB. So once DynamoDB hashes that particular key and gets to the fact that it hashes to a 3, well, that's going to lock DynamoDB into partition number 3, and it's going to be able to go zoom right there, straight on partition 3, and not have to look at any other place just to get your data. Now, what if you're not using a key? Well, then you're using a DynamoDB scan. So if you're querying for anything that is not using the key, so for instance, in this case, we're going to scan for any books by the author Finn Feline, and author is not our key. So what's going to happen now is that DynamoDB is going to have to scan the entire table, just find every item that matches that particular condition. Which in database queries we call a full table scan. Not a good thing. So there are ways around that, and we're going to look at indexes next. Let's look at DynamoDB indexes. Now the indexes are going to allow me to do well-performing queries when I'm not using the partition key. So they actually are pretty much like little tables that are running parallel to the main table, and DynamoDB is going to keep them in sync. Now, if you know something about relational database indexes, yeah, forget what you know because it's going to be pretty different. The indexes actually are the thing you're going to query on when you're doing DynamoDB. You don't actually do a generic query and DynamoDB is going to decide which index you use. No, you query the index, and that index is going to have to include whatever alternate key you predefined. Also some pointer back to the main table, so the partition key, and any additional attributes you want to query on. Now there are a couple of different types of DynamoDB indexes. We're going to look at them next, the LSI and the GSI. So the LSI, the local secondary index, where if you have a main table like this, the one we've been using, so assume the partition key is the ISBN, the sort key is the author. A local secondary index would have the same partition key, but it might have a different sort key. So in this case, you should have the same partition key, but perhaps you want to do a secondary sort by the format, whether it's paperback or ebook. Now, the advantage of the LSI is that it's actually going to be using the same partitions and share the same capacity of the main table because, well, they share the partition key. I like to say it's like my son who lives in my basement, and because he lives in my basement, he gets to use my electric bill and my heating bill and all of that, gets to use the same resources. The other thing is that if you have an LSI, yeah, all of the attributes are available for use by the index because, again, it's living in the same place. But the thing is, I have to define that as I create the table. I can't change my mind at the end, so it's not as flexible. And there are a couple other issues with it to be aware of. Now, the GSI, the Global Secondary Index, is a bit more flexible because if you take the same main table over here, on a Global Secondary Index, I can have whatever key I want. So in this case over here, I picked the partition key to be the title. In that case, yeah, I can do some very fast queries against the title because this is going to be its own little table. And when I say its own little table, it's definitely the case for the GSI because it gets its own partitions and its own distinct resources that I have to allocate. It's just that DynamoDB is making sure everything is in sync. And in this case, yeah, definitely any attributes that I want to query out of this index, I would have to include them on my index. We call that projecting those attributes to the index. But again, the nice thing about it, I can add them at any time. There's no requirement that they need to be added at creation time. Let's talk about the concept of strongly consistent and eventually consistent reads on DynamoDB. Now, strongly consistent and eventually consistent reads are something that happen in IT in general, anytime you have parallel processing in distributed systems going on. And remember that in DynamoDB, our tables are replicated so that we can have those parallel reads occurring and helping us with throughput. So how does that impact us? Well, I'm going to just focus on one partition for now. So just look at partition 3 over here that had 3 different replications and queries happening in parallel. The nice thing about it is that if I have read operations, as we discussed earlier, DynamoDB can be redirecting those queries to different partitions, and they can be happening pretty much at the same time and you're getting great throughput. That's great. Now what happens on a write? If I'm doing a write operation, so let's say I have to do an update on this particular record. Well, that write's going to initially happen on one partition, and DynamoDB is going to very quickly replicate to other partitions. But remember, very quickly is not the same thing as instantaneous. So if I'm doing an update at literally the same time that I'm doing a read, I could end up having slightly old data because when I do my update over here, I might now get a read before I get the last partition updated. So when that read comes in, yeah, it may still get the old data. Now we call this an eventually consistent read because eventually the data is going to be populated, but I already got the old one. I don't even like the term eventually because it sounds like, hey, maybe someday I'm going to get the data. It's not like that. It's like a split second. But yeah, if you're querying at the same time, you could get the data that is slightly old. Now, that may be okay in 99% of the cases, but if you're doing financial type calculations, things that you absolutely must have the latest and greatest, well, AWS is going to support strongly consistent reads. And what those are, well, when I do my update over here, when I get to this point that a query comes in, if I'm doing a strongly consistent read, DynamoDB is going to say, hold on, let me take a look. Who has the latest data? Okay, I'm going to get it from over here because I know that's the latest one. Now, the cool thing is, this is not a table level setting. You can actually pick and choose just the queries that you want to do strongly consistent or eventually consistent. Now, at this point, you might ask, well, if I can do the strongly consistent, why do I even care? Well, that's going to get to the topic of capacity, which is coming up next. Let's talk about DynamoDB capacity. DynamoDB is serverless. So the cool thing is you're not gonna have to say, I need this kind of a server with this much memory, this much CPU. You basically tell DynamoDB what is the throughput you want, and DynamoDB is gonna make it happen for you. And the way you specify that throughput is using RCUs and WCUs, or read capacity unit and write capacity unit. So there's an actual formula for that. A read capacity unit means that you get one strongly consistent read per second of an item up to 4 kilobytes. Now, if you're doing eventually consistent reads, see, I told you that would matter. You get to do 2 eventually consistent reads per second for an item of 4 kilobytes. Now, write capacity units, they are the same. There's one write per second for 1 kilobytes. Now, I'm going to show you a little bit later what that means in practical terms, but if you don't even want to worry about that, because perhaps you can't possibly calculate the amount of reads and writes you're going to get, yeah, AWS does offer an on-demand capacity where you're paying per request. So this is good if you have that unpredictable load, but it does cost a little more. So if you know a little bit of what you're getting, it pays to calculate. So let's assume, for instance, that you know you're getting a lot of reads and the rate that you're expecting is about 24 kilobytes in 1 second. So how many RCUs you would need for that? Well, remember, the formula for strongly consistent read is that you get one strongly consistent read of 4 kilobytes for 1 second. So if you're doing strongly consistent reads, you're essentially going to need 6 chunks of 4 kilobytes for this operation, or because it's 24 divided by 4, which means that you're going to need 6 RCUs if you're doing a strongly consistent read. If you're doing eventually consistent read, on the other hand, well, remember, one eventual consistent read gets 2 chunks of that 4 kilobytes per RCU. So I still need 6 chunks of 4 kilobytes, but I'm getting 2 chunks at a time. So in the end, I'm going to only need 3 RCUs if I'm doing eventual consistent read. So folks, that's why it's important to only do the eventual consistent reads unless you actually have to do a strongly consistent, because yeah, RCUs are going to directly map to how much your DynamoDB table is going to cost. That's all for today. Again, this was just a basic DynamoDB, and there's a lot of great documentation in AWS for you to get all the details. And don't forget, if you want to see hands-on DynamoDB queries being performed in Python, please check out my other video that I included in the description below. Catch you later.